let's write today's LeetCode daily. And since tomorrow I will have a lot of things to do, so I'll finish it today. Minimum number of increments. Okay. 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 So we have an initial array, and that has a size as the target. So if the target looks like this, we have 5 here, so we will have the same size as target. And each step 1, in each step we can increase a subarray. Okay, we can choose any subarray from initial and increase each value by 1. So to form the target value, at first we want to choose the full size subarray and then increase by 1. So this is our first step. And for step 2, we want to pick this 3 number, then increase by 1. So 2 to 2. And this is a subarray. And step 3, we want to increase this subarray by 1. So that will be 1, 2, 3, 2, 1. And this is equal to our target. And then return. Okay. All right. And in example 2, we got 3, 1, 1, 2. So let's assume we got this. So we will got 1, 1, 1, 1. And since we need subarray, so we can only do 2, 1, 1, 1. And we still need one more for here, 3, 1, 1, 1. And then we can increase the last element by 1. So we will have 1, 2, 3, 4. And the reason should be 4. Okay. 3, 1, 5, 4, 2. Okay. Okay, so which means that if the every value should be increased, we can just apply increase by 1 for the whole array, and this is the full size subarray. And otherwise, if these two value is already equal to the target value and we don't want to increase anymore, so the current subarray would have two parts, the left part and the right part, right? And because we want to make the initial array equals to this target array, and we can only treat one subarray in each operation, so we can use greedy strategy over here. So no matter we choose the right or the left first, the result will be the same because we cannot treat them at the same time. So let's just assume we treat the first subarray that we want to increase by 1. So we just increase by 1 here, and then we go to the next operation. And since the 2 is not equal to 3, so we treat plus by 1 here, and the next one is equal already, so we stop and we go to the next. And 3 is matched, 1 is matched, 1 is matched, and 1 is not matched to 2, so we treat this subarray. So yeah, we can use the greedy method to do so. And we can use a single pointer to looping in each round for checking whether if the current index is equal to the target or not. But this is basically just simulates the operations, right? And I think that would be TLE for this kind of big array. So this is basically the idea, but we cannot really treat, we cannot really simulate the function here. So the whole idea is how many parts we split the target array, and we can calculate it by some way. Okay, so if we got 1, 2, 3, 2, 1, and we could treat the first subarray here, here, and here. And so that would be 3. Okay. Okay, so I'm thinking that how could we decide how many parts we have in the target array? I'm thinking that perhaps we can use stack to do so. So like here, we got 3, 1, 5, 4, 2. Well, 1, 1, 2, 3, 2, 1. 3, 1, 5, 2, 3, 4. Five, 3, 2. 3, 1, 5, 4, 2. Goes in. 4, 2. Okay, so I'm thinking about that. If we're using a stack, and first come in would be 3, and we are maintaining a monotonic stack, and 3 gets in, okay, 3 gets in, and okay, 3 gets in, and 1 gets in, and 1 gets in, and while 2 gets in, we will pop out. Okay, when 2 gets in, 2, oh, okay. Okay, we have a result. And we will have a current mean. And which is equal to Okay, current max is equal to the value we pop out, so it's 1. So our result will plus, okay, so when the 2 comes in, because we want to maintain the monotone stack was decreasing, so when the 2 wants to comes in, we need to pop out the 1 over here, and we will update the current max is equal to 1. Okay, so the current max is initialized as 0, and the 1 is come out, and we will update the result plus equal to pop value subtract the current max. Okay, the current max is like this, and current max equal to the current value, and this one is pop out, right? Okay, so the pop value is 1, and subtract the current max is 0, so the result is, okay, so the result is 1 now, and the current max is 1. And the next one is still smaller than 2, so we would like to also pop out. And when we pop out this one, result will be plus the pop out value subtract the current max, so it will remain 1, and the current max it remain 1, and 3 we will I think we will also want to pop out the 3 here, because we want to make the stack empty. So yeah, we'll pop out 3. So I think it's not the classic monotonic stack. So here we would like to pop out 3, because we cannot treat the 2 and 3 together, because it has been separated by the middle, the one in the middle. So we want to pop out 3, and yeah, and just for here, the result will be 1 plus 3 subtract 1, so that would be equals to 3. Right? Well, is that does that make sense? And the 2 comes in. Okay, so when we do that, we can also append to subtract to subtract that value. So which is 1. So we can use 1 plus the result, and that will be 4. Let me check for the other case. Okay, so yeah, so for here, we got a stack. We have 3, and we have 1, and 5s want to come in. But I think that doesn't make sense because we cannot influence the 1 to over the remaining values. So yeah, well, is that bit manipulation? It fits in 32-bit integer. Wow. Oh. Actually, I don't have any idea over here. Okay, so let's rethinking about the problem. The hint over here, perhaps we want to use a sliding window for n times, and that is not really efficient. So if we're using a sliding window, that would be n squared, right? For the time complexity. So is there any way that we can not using sliding window? Oh, actually, we can just use a greedy approach to do so. So if we have 3, 1, 1, 2, and result, when we go to 3, the result is increased by 3. and we goes to 1 since it's smaller than 3, so I can assume we can use all of them together, and we will maintain the current value. Current value is 1. Okay, it's 1. And the next is still 1. So we don't have to increase the result. And the next is 2. So we can use the 2 subtract 1 because the current value is 1. So we can use the common operation for that. So and the result will be equal to 4. And the current value will be updated to 2. And if there is any other value behind 2, we can just use the current value. Right. So let me try this with the other test case. So the result is 0. And our current value is 1 actually. Okay, so it's 0 initially, and it will be updated to 1, and the result would be the current value subtract the previous value, and the results plus, so it will be 1, and the 2 comes in, we will plus 1 also, and this will be 2, and 3 plus 1, 3, and the next value is 2 and 1, and we don't add anymore because 2 is smaller than 3 and 1 is smaller than 2, so this will be 3. Okay, and for this case, okay, I think perhaps we call it the previous value. I think that is more accurate. So the result is 3 plus 3 subtract the okay, so the result is 3, and the previous value is 3, update to 3, and the next one is 1, and it's more than previous value, but we have to update the previous to 1, and it's a 5, so we need to plus 5 subtract 1 is 4, and then we will update to 5, and the 4 is smaller than 5, so we don't use it, and 2 is more than 4, so we don't update that, so it's 7. Okay, so yeah, I think this would be our solution. And for this solution, the time complexity would be O of n, and for space complexity is O of 1 because we just use 2 single variables. So result is equal to 0, and we initialize previous value equal to 0 and 4, and number in target result plus result plus in actually max 0 and subtract previous value, and previous value equals to n, and we can return the result. Yes. Okay, so this would be our today's daily.